Toyota doesn't need an introduction because, since its founding in 1937, the automaker has worked hard to earn its current standing. Is Toyota's latest 750-mile battery going to be the turning point that brings electric cars into the mainstream? Toyota is growing more confident that its new battery technology will revolutionize the electric vehicle market. Future models from the Japanese company may use solid-state EV batteries, extending the driving range and cutting down on charging times. By 2028, solid-state batteries for electric cars will have a 750-mile range and a 10-minute recharging time. According to the company's assessment, solid-state battery-equipped cars might go on sale in 2027 or 2028. Consumer decisions could be significantly impacted by this technology, as many people are still hesitant to convert from gasoline-powered vehicles to electric ones due to range anxiety. Toyota claims to have discovered the solid-state solution, which has long eluded the industry and is nothing less than the holy grail of battery technology. The new battery features a solid core between electrodes in place of a liquid one. Because of its reduced size and increased energy storage capacity, it can cover a greater distance at the same weight. Moreover, the bulky, combustible liquid cores may overheat and burst. Emergency services in the UK have responded to hundreds of electric vehicle fires since 2017. In the past, capitalism has typically seen rapid advancements in technology. It is understandable that wealthy nations now view electric vehicles as a crucial means of curbing greenhouse gas emissions and improving air quality, all the while meeting people's need for personal mobility. They offer substantial environmental advantages over cars with internal combustion engines. However, the climate issue should provide an opportunity to consider if the automobile has become too ingrained in our daily lives. Private automobiles won't be the only form of mobility in the future. To ignore the fact that the Japanese automaker's announcement represents a step forward would be churlish. In the future, an integrated transport strategy should provide a reasonable space for cars. Toyota has historically expressed skepticism towards electric cars, so any true shift in the company's views is commendable. The company had previously bet its future on its line of hybrid cars, which are propelled by both an electric motor and an internal combustion engine. It claimed that shortfalls in essential battery components and inadequate infrastructure for charging would impede a widespread transition to electric vehicles shortly. It remains to be seen, though, if Toyota can outperform its competitors, given that mass production necessitates a far higher standard of dependability and quality control. Amazingly, Toyota is willing to support fast-charging batteries in its upcoming solid-state EVs, even with the shorter battery life. Toyota's greatest advantage is its notoriety for producing automobiles that never break down. The company is banking its entire reputation on the promise that its soon-to-come long-range solid-state batteries will be able to get several quick charges before eventually wearing down. Furthermore, lessening the influence on the climate can also be achieved by using more effective mining techniques, such as lithium extraction from geothermal wells. Solid-state batteries utilize significantly less cobalt and graphite than lithium-ion batteries, although they may require up to 35% more lithium. Known by another name, white gold, is the unsung hero driving the EV revolution and the sustainable energy transition. Major EV manufacturers and nations are rushing to get lithium. There will be a far greater demand for this vital mineral than anticipated if solid-state batteries take the lead in the market. The European Union's proposed lithium battery rule mandates the ethical procurement and recycling of the electric vehicle component. The EU's policies will guarantee a sufficient supply of lithium for solid-state batteries. The regulation still needs to be finalized by European countries. The Inflation Reduction Act, IRA in the US, provides incentives for electric vehicle, EV manufacturers to obtain their batteries domestically or from free trade countries. To meet the rapidly increasing demand, the nation must increase its indigenous lithium production, nevertheless. Rare lithium businesses like the American Lithium Corporation can help in this situation. For its upcoming EVs, Toyota recently revealed several stages of superior battery technology. As we have numerous sorts of engines, we will need diverse options for batteries, according to Takeru Kato, president of Toyota's new battery facility. It's critical to provide battery options that meet the needs of different model types and customers. Accordingly, Toyota anticipates that by 2030, one of 4 new battery technologies will be used in 1.7 million of the 3.5 million EVs it sells worldwide. The popularization battery increases the present BZ4X battery's driving range by 20%, while lowering prices by up to 40%. It does this by using lithium iron phosphate, a less expensive core material, and Toyota's bipolar internal structure rather than monopolar. Even a high-performance lithium-ion battery with a bipolar inner structure is planned, though it won't be available until 2027 and is expected to provide up to 621 miles of driving range on a single charge. This high-performance lithium-ion liquid battery would have a similar range as a first-generation solid-state battery, but it would recharge more quickly. Additionally, Toyota is currently working on a second-stage solid-state battery that would provide the advertised 750 miles between charges, with a 50% increase in cruising range over the performance battery. All other things being equal, lowering vehicle weight and aerodynamic drag are 2 important ways to make EVs last longer on a charge. To achieve this, Toyota is also attempting to reduce the height of its battery packs, which will reduce the frontal and body area of the car and increase range. There will be 2 steps to the solid-state battery from Toyota. The emphasis now is on next-generation electric vehicles, even though Toyota originally planned the solid-state battery for hybrid electric vehicles before gradually integrating the technology into its BEVs. Toyota plans to concentrate on EV aerodynamics, which can be impacted by the height of the battery pack, to optimize the range of its BEVs. As usual, a vehicle's range is mostly determined by its aerodynamics. Toyota is attempting to maximize the product of frontal area, A, frontal area, and drag coefficient, CD. An EV's height is directly affected by the batteries positioned underneath it, which also affects the CDA and overall range performance. To solve this, Toyota is working on flatter battery technology, which will result in a 30mm overall reduction in EV height by lowering the battery height in the BZ4X from 150mm to 120mm. Toyota may lower the battery height for high-performance sports electric vehicles even more, to 100mm. This will facilitate the numbers Toyota is estimating for its future battery technologies and greatly enhance Toyota BEV's aerodynamics. The success of technology is largely dependent on the manufacturing process. Scalability has been an issue with solid-state batteries in the past. In addition to being costly and challenging to produce in sufficient quantities, the new battery type's severe sensitivity to moisture and oxygen further complicates the manufacturing process. Moreover, they must be maintained together under intense mechanical pressure to avoid the development of dendrites, which are metal filaments that might result in short circuits inside the composition of batteries. One of the alleged disadvantages of a solid-state battery is that, in contrast to its better performance in many EV usage scenarios, it is claimed to have a significantly shorter operational life. Toyota claims, though, that it has made enough progress in this area to resolve the problem. There will be 2 variants available: a base model with a WLTP range of 621 miles, 1,000 kilometers, and an upgraded version with a range of 750 miles, 1,200 kilometers. Toyota says that its solid-state batteries can change the game for BEVs, but the earliest possible release date is 2027. Solid-state batteries have an additional advantage over existing lithium-ion liquid batteries in that they are less prone to fire. Additional benefits of solid-state batteries. The anode's dendritic development is limited by solid electrolytes. Support for rapid charging because solid electrolytes are used, allowing Li-ions to travel between electrodes more quickly and safely. possesses a high energy density, 50–80% greater than electrolytes based on liquids, because of the high voltage operation, presence of more active components, and thin electrolyte. The use of less hazardous elements, such as cobaltaceous, decreased. Thus, it is evident that Toyota is aware of current public preferences. Toyota has to comprehend what consumers will need and want in the future, though, if it is to continue to succeed. What possible effects might Toyota's new 750-mile battery have on the auto industry as a whole? How will the demand for electric vehicles and consumer behavior be affected by this new technology? What are the advantages for the environment of using longer-range electric cars on the road? What impact will this new battery technology have on the infrastructure for charging that will be developed? What potential difficulties and barriers stand in the way of this new technology's widespread adoption? What effects will Toyota's new battery technology have on the level of competition in the automotive sector? What effects will this have on mobility and transportation in the future? How can we guarantee that every customer can afford and utilize this new technology? If you enjoyed this video and want to see more, please click the like, share, and subscribe button. Thank you for watching.